Alright, pre-calc. This is example 2 in your section 2.6. Okay, so what I need right now is for you to take out your calculator. Just get it ready. I'm just kind of clearing out my memory here. So that way it's ready to use for this example. So example 3. A wire, 28 meters long is to be cut into two pieces. One piece will be shaped as an equilateral triangle and the other piece will be shaped as a circle. Okay, so part A, I don't know why this is spaced so far out, but anywho, expressed the total area, let's call it A, enclosed by the pieces of wire as a function of the length x of a side of the equilateral triangle. Okay, so there's a lot of information in here. So you have one wire that's 28 meters long. Okay, it's cut into two pieces. One of the pieces is going to be formed an equilateral triangle, and the other will be shaped a circle. So I'm just gonna kind of draw this out. One of the pieces is an equilateral triangle. That means that all of these pieces are the same. And the other one is going to be shaped as a circle. Okay, so that's what we have now. So it says here, I want you to find the area, okay, enclosed by the two pieces, of the wire as a function of the length x of the side. So x is the side of the equilateral triangle. So this is x, and this is x, okay? Well, area for both is going to be, so here we go, area of a triangle is 1/2. Base in this case is x, okay? So I'm just going to spell it out first. Base times height. So that's the triangle. Now, because I'm looking for the area of the pieces, the area of the circle, I'm going to add. Area of a circle is pi r squared. So pi r squared. Okay, so this is the triangle and this is the circle. So now we need to find, and it wants it in terms of x. So we have to find what the height is. Okay, so here's the height. This is 90 degrees. Would you agree that if this whole thing is x, then this is half of your x? Okay, so from here to here is half of your x. Okay, well, to find the height, I'm just going to use Pythagorean Theorem. So here we go. A squared plus b squared equals c squared. So this is what h, I'm going to use that for h, okay? And I'm just going to do, let's see, the work. How about over here? Okay, so Pythagoras said, hey, it's really a squared plus b squared equals c squared. Well, a is going to be 1/2 x squared. Okay. B is going to be this height, whatever this height is. C squared is now x squared. I'm really trying to solve for the height because I want it all in terms of x. So this is really 1/4 x squared plus h squared equals x squared. I'm going to solve for h, so moving these over. So h squared equals x squared, take away 1/4 x squared. Okay. Well, common denominator tell me that I'm going to need 4/4 x squared, take away 1/4 x squared. So h squared is going to be 3/4 x squared. Because they're both x squared, I can totally combine them. I'm going to now take a square root. Normally when you take a square root, you should have a plus or minus in front of here, but because h is in height, so h is going to be a positive dimension. Okay, so this is really 3/4 x squared, which can be simplified as this. When you have multiplication and division on all into the radical, you can actually break them up this way. So radical 3, we can't really do anything with that, so we're going to keep it as radical 3. Radical x squared is now just an x, and radical 4 is 2. So this is what h is in terms of x. Okay. So what I'm going to do now is area equals 1/2. The entire base of your triangle is still an x. See this right here? So the whole thing is, we use half of it because I just want to use the right triangle. You can only use Pythagorean Theorem if it's a right triangle. So base is now an x. Height is normally h, but because we have to put it in terms of x, so height is radical 3 over 2x, okay, plus pi. Now I have to get rid of, so here's your radius, okay. Now your radius is this, whatever r is, but I can't have r. It all has to be in terms of x. Now what we're going to do is this. You have 28 meters long, okay? This whole thing right here is going to be this plus this, the circumference or the outside part of it, right, to make them equals 28, so which I'm going to write over here, okay? So the circumference or the perimeter, so all of this plus all of this equals 28 meter, okay? So that's what it's for. So this 28 meter is really the perimeter of the triangle and the perimeter, or aka the circumference of the circle. Well, if you look at this 1x plus 1x plus 1x, that's 3x's, okay? If this is 3x's, the perimeter or the circumference of this is now 28 minus 3x. Would you agree? Equals circumference. And the circumference formula for a circle is 2 pi r. So what I'm going to do here is, again, I can't use r, so I have to solve for r here. So I'm going to divide, if you look at this, I can just divide each and every term by 2 pi. So I'm going to go and divide it by 2 pi. And you know what? Maybe I should do the work right. How about right here? Okay. Alright, so we have 28 minus 3x equals 2 pi r. Well, divide each and every term by 2 pi r. I'm sorry, just 2 pi because I want to solve for r. So r equals 28 minus 3x over 2 pi. You can leave it just the way it is. Some of you like to write it separately, and that's really up to you. You can also write it like this. 28 over 2 pi minus 3x all over 2 pi, which 28 over 2 pi can be reduced a little bit more. So this one can be seen as 28 divided by 2 is really 14 over pi minus 3x over 2 pi. So it's up to you to leave it like this or like this, because it's not gonna, it doesn't look like it's any better. So I'm going to take this out, okay, and put it back up here. So whatever this is square, I'm just going to use this, 28 minus 3x all over 2 pi. And from here, I'm just going to see if I can simplify a little bit more. Okay, so express the total area enclosed by the pieces of the wire as a function of length x. That means I can only have x's in here. So a of x is now x times x is now x squared. 1/2 times radical 3 over 2 is radical 3 over 4 times x squared. Okay, this one there's not much we can do, so I'm just going to leave it exactly the way it is. But you can simplify these out. Okay, so I'm going to write add pi times 28 minus 3x squared on the top. On the bottom is really 4 pi squared. But there's a pi here and there are 2 pi here, so one of it can be reduced. So my final answer is a of x equals radical 3 over 4 times x squared. Again, this is going to be canceled with that one of those. So there's no more pi on the top, but on the top I should have 28 minus 3x all in quantity square all over 4 times just 1 pi. And box this up because this is what it wanted. Okay, so it wanted the total area enclosed by the pieces. That means both pieces. Just in terms of x. That means only x can be in here. Pi is not a variable, by the way. Pi is about 3.14, but when you put in your calculator, make sure you keep it as a pi. Okay, so all of that is just to write the area. So make sure you listen to it again, please, if you don't understand. Okay. All right, let's move on to part B. What is the domain of A? Well, keep in mind, A is the same as A of x, which is this piece over here. I'm just going to copy it over. Radical 3 over 4 x squared plus quantity 28 minus 3x, all of it squared, all over 4 pi. Okay. Well, remember, x was defined right here. Domain is all x's, and x is defined right here. X is the length. Okay. X is the length of the equilateral triangle. So the domain of that is, you can think of it a couple of different ways. You can have a lot of it. So out of the 28 meters, you can have almost all of it being the triangle, okay? And then a very small amount of it, this is the extreme, and very small amount of it being the circle. So if you wanted to, you can say, hey, 28 divided by 3, 28 divided by 3 is 9.3 repeating. So, but you can't include it. So here we go. Domain is X can be, not including. So the most it can be, okay, so the most it can be is leaving 28, all of it here. So that means 28 divided by 3. Okay. Keep in mind that I'm using all of it for the triangle, not all of it, most of it for the triangle, and very small amount, almost near 0 for the circle. Or the other extreme is that I'm going to use all of it for the circle and almost nothing for the triangle. So these are the two extremes. Okay. So this right here, meaning that I'm using all of it for the triangle. This right here means I'm using nothing for the triangle, or almost nothing. That's why we're not including the two extreme, meaning we're leaving a very small amount for the other one. Okay. All right, we are on the last part here, which is C. Graph A equals A of X. Okay, and then it says for what value of X? That means I'm looking for X. Is the area, what means the combined area, the smallest. So here's a little sketch for us. We're going to have to label the x-axis. The x-axis in here is the length of equal triangle, equilateral triangle. Okay, since I'm kind of running out of space, we're going to abbreviate this. And the y-axis is going to be area. I'm going to use my calculator, so this is all on calc. I'm going to punch in my A of X, which is right here, and cautiously put the correct parentheses in the right places. So here we go. Radical 3, close it, okay, divided by 4. I'm just going to put this in quantity, the whole thing. And then I'm going to put it in x squared. Then again, I'm going to add, because this whole thing is its own piece. So I'm going to open with the parentheses. 28 minus 3x, close it, and it's being squared. Okay, and that whole thing is divided by 4. And you have to use pi as pi. I don't want it rounded until the very end. So this is what I have as my area formula for the combined shapes. Okay. Then from here, I'm going to go to window. We kind of stated a window already, so that's what I'm going to put in. So 0 to 28 divided by 3, 28 divided by 3. And I'm going to do zoom and zoom fit to see what it gives me. Okay, so look at it. Okay, we put in the window 0 to 9 point repeating, and it didn't really give us anything that we wanted. So I'm gonna, obviously y is the area, I can't have 0, so I'm just gonna modify it to maybe 100. Okay, so I know there's some minimum value somewhere over here. So what I'm gonna do is I'm gonna extend my x-axis. Right now is 0 to 9, so I'm gonna do 0 to 20, like twice the size. There you go. So now I have something that I can use. And I'm looking for x when the combined area is the smallest. So here we go. Second trace, minimum. Go all the way to the left. Go all the way to the right. And here we go. So let's look at this really quickly. It says here, graph A of x, which is what we have. For what value of x is A smallest? So we're going to spell this out really quickly. The smallest combined area is, this is the area, this represents the area here. So let's rule of thumb, run to 2 decimal places. This is 35.54. 35.54. And our unit of measurement, excuse me, meters squared. when x is, this is really what it's wanted to know, this right here, when x is. And x is this one, 8.79. 8.79 meters. Okay, so this is really what it's looking for. But I'm kind of going above and beyond and stating the area as well. Okay, now let's sketch it out, and then we're going to have to kind of plug it back in to make sure that it's it fits the perimeters. That means it fits all the restrictions. Okay, so let's just second table really quickly to get some values. When x is 0, I have in the 600. Well, I don't need that much. How about let's, I guess, label it by 100. So 2, 4, 6, 8. Okay, 10, 12, 14, 16. So this is 2, 4. So this is 100, 200, 3, 4, 5, 6. Okay. So it looks like it's going to be really, so when x is 0, it's going to be in the 600. 1, 2, 3, 4, 5, 6. And then the extreme would be 8, right? When x is 8 is the smallest. According to this, when x is 8, it's about 40 point something. So 8, so I'm going to go about halfway. And the other extreme is 16. When x is 16, I have 425. So 16, 10, 100, 200, 3, 4, 425 is right about here. Just kind of using my table to give this a little sketch. Okay, so that's the curve. Alright, now let's check to see if this is going to work out. Okay, so when x is 8.79, let's add it up really quickly. Make sure we don't exceed 28. Okay, so 8.79 times, I have 3 of them, so times 3 is right now 26.37. And then that means the rest of the circle is really tiny. So if I take 28 minus my answer, it's 1.63 meters. So the rest of the circle is super tiny. It's only 1.63 meters combined for the entire circle. So looks like if you're looking for the smallest combined area, you give this the largest, or you give this the most perimeter, or the most meters of the wire. Okay, so this is it. This is the end of our notes. Let me zoom out to give you the complete picture. Alright, so I should really tell you a joke, right? So here we go. Why can't a bicycle stand up? So why can't a bicycle stand up? Because it's too tired. Haha, it has too tired. So instead of like T-O-O as too tired, this is spelled T-W-O. You got it? Alright, have a wonderful day, and I will see you in class.